Good morning students, myself Sushmita, Assistant Professor ECE RCET. So in this session we will be learning about antenna arrays. So on completing this particular video you will be able to explain what are the different types of elements in an antenna array. Also you will be able to differentiate the different types of arrays. So in this video we will be seeing introduction, elements of antenna, gain or directivity of antenna, and then types of antenna: linear, circular and planar. Let's see one by one in detail. First, introduction. So antenna composes of elements. There will be elements that has low values of directivity. In application case, antennas are required to have high gains. So to achieve greater gains, what we have to do is we have to increase the electrical size of the antenna by enlarging the dimensions of each single elements that are present within the array. So the most efficient is to use an array. So what is an array? An array is a set of two or more antennas. The signal from antennas are combined or processed in order to achieve improved performance over that of a single antenna. So that is the antenna array. So tasks that are performed by antenna array. So first point is they will be increasing the overall gain. So instead of using a single particular antenna, we will be using n number of antenna that is connected together to form an antenna array. So such that it will be producing the increased overall gain. And next thing is it will be providing diversity reception. Third most thing is it will be cancelling out the interference from a particular set of direction. So interference will be cleared easily by using this antenna array. Next thing is it will be determining the arrival and direction of incoming signals. And fourth one is to maximize the signals to interference, also the signal to noise ratio, that is SINR. So now let's see the type of array. So first thing is a linear array. So linear array is nothing but, as the name indicates, it will be in a linear pattern, that is antenna elements will be arranged along a straight line. And second point is elements of the array are uniformly spaced, that is they will be having a fixed space. If that is suppose if antenna 1 and 2 is placed between at a distance of 5 meter, and then second antenna will be placed at the same 5 meter. So that is equal spacing will be provided between two antenna array elements. Next one is classification of linear array. So here we have two types of linear array. One is 2 element array and another one is n element linear array with uniform amplitude and spacing. So 2 element array is nothing but we will be having two different types of elements that are being connected, and n element array is we will be having n number of elements with uniform amplitude as well as spacing. So as I told in the previous slide. So now coming to the 2 element array. So here we are having 2 elements. You can see in the PPT it is indicated as 1 and 2. And now the electric field E1 and E2 is given by the mathematical expression, where M1 and M2 are the field magnitudes, and En1 and En2 are the normalized field patterns, and R1 and R2 are distance to the observation points, and beta is nothing but the phase difference between feed of the two array elements, and rho 1 and rho 2 are the polarization vectors of the far zone E fields. So when these antenna array elements are said to be identical, they can be given by a single expression such that it connects all the equation, that is En of theta comma phi is equal to En2 of theta comma phi is equal to En, that is up to any number n value we will be having same number of theta and phi. So they can be oriented in the same way in a same identical polarization, that is rho 1 is equal to rho 2 is equal to rho. Similarly, since their excitation is also of the same amplitude, they can be also indicated as M1 is equal to M2 is equal to M. So coming to n element linear array with uniform amplitude and spacing, we can say that an array of identical elements with identical magnitudes and with a progressive phase is called as uniform array. So E total is equal to E1, E2, E3 up to En. Similarly, E total is equal to the total of all the current value that is being considered in that particular antenna is taken into consideration. So far we saw about linear array. Now we are getting into next type, that is circular array. So from the name we can say that it is arranged around a circular ring format. So where in particular the circular array are used is, they are mainly used in radio direction finding and then air and space navigation, underground propagation, radar as well as sonar. So this is the graphical representation, that is diagrammatical representation. Also the distance Rn can be calculated by this particular equation. So one most thing that we have to note in this is, where in case of linear array we will be having linear arrangement, but in case of circular arrays they can provide 2D angular scan, that is both horizontal 5 and vertical theta scans. Unlike 2D planar scans, the circular arrays are basically 1D linear arrays, but whereas in circular we can obtain 2D forms. So another one thing is, circular array can scan horizontally for up to 360 degree without any distortions. That is the main point that we have to note in circular arrays, that is it will be having 360 degree with no distortion near the end fire directions. So next type is planar array. Planar array are more versatile. So we can see the antenna array elements can be arranged towards some planar surface. You can see in the PPT we have taken a rectangular array and the antenna array elements is placed over the planar surface, and it will be having some symmetrical patterns with the lower side lobes, and coming to the directivity, it will be having some narrow main beam. And applications where this planar arrays are used is tracking radars, remote sensing as well as